Yeah, so the recording started. I missed a little of the banter about why not to use order char on this, simply because you don't know what they do yet. And even if you read about them, you still don't know what they do. You never had to use them other than to draw a chessboard. It wouldn't be my first choice ever to use those commands, especially character char. It's funny because I know a lot of people didn't even do help. Let me share my screen. It might help, right? Ba, 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 ba. Share my screen. Good now. Okay. So like when you do help on char, what do you get? Well, it's a built-in function. Char built-ins take some I and a slash, return a Unicode string of one character with ordinal. What does it even mean? Huh? Why would you use? Why are you searching for a Unicode? Could we have used lengths at lens? Lens or lengths? Lengths is all right. Lengths of a string, totally. But I mean, this right here using character, it's all over DigitalOcean or digital something or other. I have like 4 links to the same script that 9 people turned in. Um, and here's a pro tip for everyone whose English is a second language: don't cut and paste comments that are perfect English, and make sure your friends and people you know who also speak English as a second language who take this class don't cut and paste the same comments, because 8 out of the 9 people had the same comments. That's a little weird, don't you think? Like, comments are they're organic, they're made by you. When you cut and paste comments from a website to your own code, it sticks out like a sore thumb. And like misspelling a word like chest instead of chess, a chessboard, CHEST, and having 4 people, same line of code, misspell chessboard. Come on now, at least proofread what you're trying to cheat. It's just a sad day. Yep, length will be it. I'll show you how to use it, but just if you're gonna copy, get good at copying, and try to you're trying to beat a pro copier here. I mean, I was in your place. I sat in those seats. You're not fooling nobody. Let's draw a chessboard real quick. Everybody ready? So I'm going to say let's. Let's is short for letters, and I'm simply going to go A, B, C, D, E, F, G, H. No need for a list, because a string, A through H, is a string made up of strings. And you proved in your challenges and through your reading, if you did them both, that you could iterate through strings. So what do I mean by that? You could say, for each let in let's, print let, right? Save it. I'll save it something silly. I'll call it let's call it chessboard, right? Chessboard. That's funny. Chessboard, hit F5. That's what you get. It iterates through the strings for you. For A in my list, print A. For B in my list, print B. For C, and so on and so forth. Well, now we could use a range. I've seen a lot of people do this. Go nums equals, and then 1 through 8, or they did a list or a tuple, and some did a tuple, some did a list. We'll do a list, but I'm not going to do a list. They did this: 1, comma, quote, 2, quote. Okay, what does that do? It gives you a list of strings that represent integers. So 1 and 2 are really a string, right? Cool. That's a good way of doing it. Waste of time, right? Because you could simply say, for each, what do you want to call it? For each num in range of, you count backwards, 8 to 1, so 8 comma 0, 8 going backwards to 0, stopping at 0, counting backwards by -1. So that'll give you your 8, 7, 6, 5, 4, 3, 2, 1, right? And now you got your nested loop, which you could just tab over. So let's try to win this really quick. From range, each num is going to be a string. Let's just agree here and say each num is going to be a string. Cool. So what can we do here? Well, in your second one, or wherever you want to, num equals string num. Or you can even do this in your print, but I prefer to do it outside the print so I don't mess it up. And now I have this string called num. I don't remember what issue I had trying to use it like that, but it kept giving me an error trying to do let's equal A, B, C, D. Maybe it was looking for an integer and didn't like, yeah, perhaps, Olivia. Yeah, I left you some pretty good comments. I like seeing your work. Your work was really cool. You really beat yourself up, and you put it all on the line to try to win, and I thought that was awesome. So let's take a look at what's a chessboard. Is it letter number or number letter? It's letter number, right? So we have let plus num, which is now a string. Save it, hit F5. Okay, cool. So now I got this A8 through H8. Sort of cool, is it? This is what we want. So we can toss an end in here. Sort of getting there, right? It's not 100%. What do we need to do here? Let's think about it. Any ideas? Anybody catch it? And maybe a sep, maybe no sep at all. How would we win here? Well, this is kind of creative, right? You can start putting in where you think you need prints. Well, so for every letter, now think of this: for every number, 8 hard return. So for every number, if I just printed a hard return, maybe I don't even need it. Maybe. Oh man, now I'm getting busy with it, right? So I got my A8 through A1 and my H8 through H1. Does this meet? Let me pull up the website here. Does this meet our initial requirements? Let's take a look. Course lessons. I'm just zipping through. I'll pull it over on our side. We won't beat this up too much. Yeah, it looks a little bunched up, but all in all, A8 through A1, H8 through H1 looks about right. Then they want some lines and some hokey pokey pipes, right? But in essence, we beat the first one. We beat the first one with nothing crazy, no char, no ord, no lists, only everything we covered from lesson 1, 2, and 3. Told you at the beginning, I'm not here to steer you wrong. I'm here to tell you to master the fundamentals. So what does that mean? When I say master the fundamentals, it means master the concepts that are mentioned every week. I don't expect you to code with complex things we haven't covered yet. We simply didn't cover them yet. If you know the material up to now, you will succeed that week. There's no tricks. I'm not tricking you. I know Google's your friend and people like cutting and pasting and stealing code and borrow ideas, not code, right? Rewrite it your own. Understand what you're trying to read or copy. I'm not saying just use the course material. If you're more comfortable thinking you could find a better answer than your book, the challenges, the videos, the coursework, and me, good luck. This entire class is designed around that book. So either get really good with Google and searching for the author of the book and the book, or just follow the material. Give yourself time to be successful. And trust me, when I see the time created of your script, the date of the file, and the time last updated, and the time turned in, and it's all within 3 hours, I know you didn't give yourself a lot of time to work on this. You got 2 weeks. Read, perform the challenges, watch the videos. While you're doing that, start to build your ideas on how you're going to get the script. The group exercises and me kind of point you in the right direction. I want you to learn the course material every week, master the fundamentals. If you won't, like I said, if you want to go out on your own and try to fix this, go ahead, but you're not going to win. And like I said, the banter for a lot of people who showed up in class today, it's not for you. It's for the people who need to hear this. And I appreciate your patience and understanding on that. But some people, they need to hear it. Now, if we just change this to an end, let's cut and paste this. Let's always have this roll, and we'll just do it again down here. And instead of ended, I'll just throw a pipe in there. Save F5. Okay, so we've got our first one. Now we got our second one. So what all do I need to add? A print statement, right, with dashes. We
Your
could
line
save,
break.
yeah, the line break, right? So we could save it as line break equals, and we could do a dash times, I don't know, I'll just say 34. I'll just throw something out there, right? Quote that. We'll see how that goes. And we'll just say, well, let's think about where we have to print it. We have to print it up top very first. We'll get to that. But then we have to print every complete iteration of number and letter. So what I mean here is every iteration of number and letter, right here we have to put that sweet line break. So where does that take place? Right here. Gotta spell it, gotta do no caps, right? Print, let's go line break. Let's see if this is right. Oh, what happened? Did it perform the line break?
No.
All right, do I need these? Oh, invalid syntax. So I need something. So how would I get that to work?
You're putting the quotes around, Olivia pointed out, around the 34 as well. It
There we
should
go.
just be the line, right?
There we go. Good eyes. Ah, invalid syntax. Invalid syntax for days. Or dash. Let's try that. See, the thing here is I'm walking you through this. I've done this plenty of times. This is for you to see the trial and error is okay. It's your code. You can adjust it very quickly. Sweet. But you notice we told it to end with the pipe. So there's no hard return.
I have a comment.
Yeah.
Remember that fancy new line that you had above let? Couldn't we put it there because we created a new line every time, and then we put line break?
Above let's up here.
No, above the for loop for let, where you put new line after line.
Totally. We're going to.
Okay.
We're going to do exactly what you said. So here we go. 34 is too big, right? Obviously, like I messed that up, and the hard return gives me extra space, and it's not perfect yet. Let's not go for perfection. Let's just go to get this cleaned up a little bit. And you said right before that new line, print the line break. Now we got our doubles. You see where this kind of starts to become silly. So do we need this anymore? Okay, I like where that looks, but I'm getting doubles. So this only needs to print once at the very top. So print once, we're in a loop here. So this is going to print this as many times as there is my loop. If we remove this, and put it up here, put it outside the loop, and now we have that. Oh, what happened? Where did it print? Did it? Let's take a look at this. One right afterwards. And then this. Where is that initial one? Doesn't look like it printed. Let's comment this one out. Let's rerun that. Oh, there it is. So what botched that up? Nothing. Just memory somewhere in randomville. But now we got it, right? Let's accept this. Let's go, okay, we got this. 34 is too much. Let's drop that by 10. Let's go 24. Let's see where 24 looks. I'll take it once we pop everything over once. Do I add a space? Or do I try to remove this? Because remember, this print is really coming with a separator, and it's saying new line, space, my line break, because the default value for SEP is indeed a space. So let's take that away. Let's say no space. Ah, there we go. It's all the way over. So I can just cut and paste this. Nothing tricky. If you paid attention from lesson 1 to lesson 3, this is everything within the book. Well, not everything, but there's no tricks. There's no joking around. I'm not pulling your leg. I'm not telling you to go research the entire internet to recreate this. Literally, for each number in my list of numbers, 8 to 1, and for each letter in my list of letters going A to H, print a letter and number next to each other. That's all it is. How do you get a pipe on the left side? I couldn't figure that out. Okay. How could we? The lone pipe on the left side. This is a good one. There's no start in print. There's only end and a pipe, right? There's nothing really cool. So can we start to add logic? Like right before this, can we put if, let's say let is equal to A? Then print. What are you going to print? You're going to print your pipe, right? Plus let number. Right, does this work? Oh, error. What did I do wrong? Like a cat and date a string and not an integer. So what does that mean? Oh, see, I need to turn it to a num to a string. I could do it right above before the if statement, but you know what? I will do that. Cool. There we go. Pretty cool. And I'm not expecting it to first time go this stuff, you know? It is very difficult. I think that was the error I got trying to do let's ABCD. Okay. Yeah, perhaps the integer and the string. And that's because the number itself is an integer and you're trying to concatenate or add them together. And they're two different object types. But the minute I change them both to strings, you could add them together all day long. All right. So that's cool. And but what I don't like is you could toss a SEP in here just for fun and equals nothing, save pipe now. And now it's all tightened up. And now we got to change this to 20. I'll change to 25, see what's up. That's pretty good. I've done this a lot, but the key is to focus on what you've learned up until this point, not to go hunting off on the internet for, hey, Google chessboard, Google chessboard, Google how to draw a chessboard, or Chat GPT. Once again, we got a couple Chat GPTers too. And if you're going to get tricky, at least at least start a Discord, communicate with your fellow students, and go, hey, who's using ChatGPT? Because so am I. Let's not get the same thing identical. Because there was a variance of I had so one script popped hot 9 times, one script popped hot 6 times, one script popped hot 4 times. So do the math there. That's a lot. That's 20, right? I have 80 students, give or take. So 1/4 are waiting to the last minute and attempting to cheat. And you stand out like a sore thumb. Your code's the same. The kilobits of your code is the same. Certain lines, it's just stop it. Right? Take the time. A couple people beat themselves up and turned in code that wasn't working. They still got 10s. I saw their efforts. They were right there. If they had 15 more minutes of sleep, they would have got it. Or if they got up and walked away and came back, they might have had it. But it's not perfection. It's critical thinking skills. Copying someone else's material is not critical thinking. And you will get fired. Like if you do that at a job, if you copy some BS from the internet and use it in production code, someone's going to fire you. They're going to be like, hey, man, good job. The first time we let it slide, second, third, fourth, fifth time, that's too much. That's too much public domain inside our program. Goodbye. So don't do that. I know script kiddies out there, they hate to think hard and they go for the target, especially red teamers. Stop being an amateur. I take breaks. That's the best advice ever. Take breaks, walk away, get up, go for a walk, take a shower, cold shower, hot shower, drink a tea, coffee, do something. It's best. Good advice. Solid advice, Olivia. But this is something along this line. There's like a couple different ways you could do this by placement and moving your for loops around and stuff like that, and using a list if you wanted to. I have no problem with that. We went over lists a couple times because I knew a lot of you would, right? So you could use a list here, you could use a list here, but the entire lesson was about loops and range. While and for and range. Use them. If you find yourself pondering, should I put this in my script? Have I learned it up till now? Is it this week's material? The answer is yes. Right? Just keep that in mind. But here's your chessboard. Chess, 2 S's, not a T. Chessboard, right? Not bad. And remember, call them what they are. Number, letter. What does a chessboard look like? Letter, number. Okay, then I'm going to print letter, number. Calling it X and Y and confusing yourself and flipping them around, and it doesn't help. And when you call things X and Y, right away it's a red light that you may have copied the code, because programmers, when they put stuff out in the public, they call things X and Y and Z, but when they use it internally, they actually name their variables what they are. So just keep that in mind too. Like it sticks out like a sore thumb. But that's it. Any questions on this thing before we 86 this thing? We forget about it and move on? Because now you're going to see Happy Zach. Moving on to lesson 4. Happy Zach. It's a good thing though, right? This is my favorite lesson out of all the lessons. It's also very difficult. This is the next 2 weeks. Pay attention to this material. Take your time. Start on the challenges. Read the material. Start on your script as soon as you can. Rock, paper, scissors is no joke. If you remember everything up until now, script it without a function first. Go back, put your functions in later. Pro tip for this lesson. Especially if you're not used to using them, it'll let you get your mind right, let you build your functions, let you code. And if you see natural white space between blocks of code, those might mean they might be better off as functions. What do I mean by that? Well, we'll pseudocode it later, but we're still going to go over the material and have some fun. But everybody ready to dive into this thing so far? This seriously is my favorite lesson. Like, it really is the coolest lesson I think that we do. And I'll tell you why. It shows you that you could build your code and it's reusable in more ways than one. So it's like super flexible, super awesome. And we'll start off with, one. So there's a lot to take in here. This lesson talks about type, integer, float, format, range, dir, print. All these we should understand these by now, right? We've learned all these. These are built-in functions that help you be successful. The concept of building your own function shouldn't be too wild. Tell me about it. Yeah, I started to change. You're good. You're good, Logan. Like, functions are reusable pieces of code. That's it. Programs, code, scripts, whatever you want to call it. They're just reusable tiny pieces that are very effective in doing usually one thing really well. Sometimes people wrap up a bunch of stuff in them. That's fine too. But you are the creator of your own functions. And you'll see really quickly that sometimes less is more, sometimes more is better. And you get the gist of it. But they also cover min-max. Min-max is pretty awesome. I'm going to run through these really quick. I'm going to kill this. We'll get a fresh one. So where could these lend you a hand? Built-in function called maximum. It shows an S. How does it know that that S is maximum? What if I did that? What if I hit the up arrow and changed it to a capital S? Still the lowercase s. What's the difference?
It's I can't remember specifically, but they're stored as a value somewhere.
Right.
Yeah, I don't know what that value is called anymore.
Doesn't matter. Don't fall. That's not ASCII. It's a Unicode value. And you can get that by doing the opposite of CHR character and do ordinal. Or let's see if I'm right. It's been a while because I even avoid them. It's ord. So you call in the ordinal of S and it gives you 115. Well, let's call in the ordinal capital S. It's 83. So the maximum value, because remember, Python doesn't know what an H is. It knows what an ordinal is. Then it could take that to hex, turn it to ones and zeros, and then display a symbol for you. That's what Python knows. So this max on a string is going to give you the max Unicode value of that number. Let's see if I'm right. I could be wrong. Let's do a help on ord. Built-in function ordinal returns a Unicode point for a 1-character string. Awesome. That's it. So max, when you pass it a string, will determine the Unicode values of each character and then display back the character with the maximum value. Different if you throw in a list of integers, floats, integers. This comes back and it actually knows the integer value. So it represents the true value of the integers, right? Yeah, is the latest. Whatever is the latest. Yeah, because it's, yeah, you're right. It's Unicode. But max works differently against integers. It goes by the actual value of the integer, the represented value of the integer. So they're two different things. Well, guess what min does? Min does the inverse, the minimum. So how can we prove that? Well, a space. Well, how do we know a space is the? Well, I can check it. No, my bad. I'm breaking everything tonight. Let me break out of that. You'll see. Let's do the ordinal of a space. Space, quote, 32. The value of 32. Well, what's an A? 97. So do you think special characters have lower numbers? Maybe. At least in Unicode, right? So min does the opposite of max. That kind of makes sense, right? Now the string, or let's look at the integer. A minimum of value is 4. That's what you get back. Very helpful. This is insanely helpful for max and min. You could do things in the near future, the next lesson, lesson 5, where we go back to strings and we learn more about them. You could do things like if you had a list of computer names and they all say C starts for Columbus, P is for Phoenix, CA is for Canada, right? You could do things to where the min-max values, you could strip off the first 2 characters and see if they match, and then or use the min-max values of those, even the Unicode values of those strings, to do your search throughout your entire list. You could do a lot of wild stuff with min and max. We're slowly progressing to how crazy we can get with that towards the end of the class. For now, just know that max on a string gives you the Unicode value. Min, same thing, gives you the minimum. Max on an integer gives you the maximum integer. Min on an integer gives you the minimum. That's it. Now, the length function tells you how many things are in the argument you pass it. So here we have hello, class, and there's a space. 11. Count those up. There's 10. Counting the space is 11. A space has a Unicode value, which we already proved, of 32, so it's an object. And when you put a space in a string, either in the beginning or the end or anywhere in between, length will count it. Keep that in mind, right? So that's why when data analysts get data, we look at the front and end of the strings, and we do what's called stripping. We strip all spaces on the front and end. A lot of programs will give you data from a field, and it'll end it with a space. It messes a lot of stuff up, believe it or not. So you have to clean up your data by removing all the spaces, and we'll learn how to do that. Pretty cool stuff. And length on a list of integers will tell you 5. So basically what this is saying, you have 5 items in your list. And you could also do length against a list. Once again, my list equals, and we'll build a list. We'll say 1, 2, 3, comma, we'll throw an A in there, and we'll throw a word, Timmy. That's good enough. And let me remove that period and put a comma like I wanted to. And now when we call on my list, it prints everything out, shows you that's a list. If we do length of my list, it'll return 5 because there's 5 objects. 1, 2, 3, 4, and 5. Pretty cool. Super important to know those. They're very helpful. Any questions on min, max, or length before we move into define? Because this gets pretty fun. It's really fun. So let me just hit enter here to pull that over. So let's talk about the define keyword. It's an identifier for a function, right? It's followed by parentheses if you plan to fill them or not. And they hold for all essence variables. And it ends with a colon. It ends that definition statement. So this is a definition statement. Define test1, open close parentheses, colon, enter. That's the definition statement of that. I defined a function named test1 with no arguments. And then after it reaches no arguments, what test1 is going to do is it's going to print hello. Go to the end, hit enter. Now I'm in the shell here. We have some people turning in shell code. Stop cutting and pasting from here. Go to File, New, type it out like I do on the left, then save it. If you hit turn in shell code, it doesn't run because it has your answers, no comments, and it actually does copy the, excuse me, the greater than ellipses out. So here we use define, called it test one, no parameters, and every time we call on test one, it's simply going to print the word hello. Test one, enter. It didn't print hello. It told me where it is in memory. To call on a defined function, to call on something you define, right? You have to open and close parentheses and hit enter. And you get back hello. Pretty cool. What if we said it takes a single argument and we'll give it an X and we'll say hello, comma X. And now I'll call on test one and I'll throw Tim in there. It takes that argument or parameter and then passes that variable to the statement inside of your definition statement. Pretty cool. Everybody like this? What do you think? Anybody have any questions about these strange things in the parentheses?
Just to confirm, the strange things in the parentheses are parameters, not arguments, correct?
Let's talk about that. We're going to talk about that.
Okay.
So, which is good because there, a lot of scripters, a lot of programmers use those terms interchangeably, right? They'll say, "Oh, arguments are parameters," blah 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 blah. But as we move on, you'll see that parameters are the functions, input, past if. So there is a difference between a parameter and argument, but in all intensive purposes, you could use those interchangeably. What is a Java equivalent to def? I don't care. I think it's make or something like that. Yeah, something like that. I forgot. It's been years. I stay away from that nonsense. Just be honest. But so let's get back to the parameter. We'll go back to that in a minute. But parameters and arguments, right? So when you set a function up and you say, hey, test one X, it's a parameter. It's a space holder. When you call on it and give it an argument, you pass that argument with a value. So a parameter is a space holder. When you give it a value, it becomes an argument. Sound pretty simple? Simple enough? But that's it. That's function in a nutshell, but we're going to tear it up. We're going to tear it up a lot. This is important right here. The define statement, give it a function name. The function name follows the same rules as variables. No, can't start with a special character, can't start with a space, no keywords. Like I can't define another function named print, all lowercase. It'll get angry and say, you can't use that. Let's try it, right? Let's try to define print, open, close. And I'll put print, I'll call on print itself. And I'll say test. Now, if I call on print, or will it let me define use keywords? It will. Oh, what happened here? Print calls on print, which calls on itself. So now I got a mess here. Just because you can doesn't mean you should. So it's best practice not to use your keywords. Does anybody remember how to get your keywords? This keyword. Obviously, I don't. There's something called KW list. So now if you go keyword KW list, oh, didn't like that. How do I call on it? Anybody know? Just like that. And these are all your keywords. I think there's 30 some. How could I count these? Exactly, Logan. Good job. So what he means is, since it returned a list of objects to me. And a list of objects best friend quick to count is just length. And then throw that command in there. Since it returns a list, we're basically saying, what is the length of the list returned from keyword.keyword list? 35. So these are your 35 keywords, right? So there we put length to the real world test. Excellent. But remember, when you define your function, give it a good name, similar to variables, no keywords, arguments if you need them, or parameters. You'll hear me interchange that too, so let's not be sticklers about it for now. A colon ends that function definition, and then these are the statements tabbed over one, kind of like a for loop and a while loop, or if statement. These are the statements that your function will perform. Well, what can it perform? Anything you've learned up until now and more. You could put loops nested, if statements, else statements nested. You could do nested prints. You could do whatever you want inside of a function. Pretty awesome. So let's take a look at this, right? So we kind of beat this up already. We already had a one to print hello. No parameters. We already talked about no parameters. Used to pass different values in and out of it. And you're going to learn, we're going to cover this next week too. You can have as many parameters as you want. You could even give default values. So when would you use a default value when you're writing a function? I know it's kind of a loaded question right now, but like if I was to define something called get middle name, and I put x equals quote NA. Right? Now follow me on this. Get middle name, no parameters. What do I get back? Takes one positional argument, but one was given. Okay. So what does this x equals means?
You basically have to give a middle name. It won't let you run the function without it.
Well, how can I get it to run a function without it?
I don't know.
Oh, we're going to learn that, right? Because now if I put NA in here, if I put Tim in here, it gets bad too. It's like, I don't know what x equals. Like x equals what? What's going on here? So there's something with the syntax that isn't right. Okay. We're going to learn that next. And I'm going to show you it coming up. I just want to get your minds ready for this because this is coming up. Positional parameters, positional arguments. Now we're going to get to it. Trust me. Just heed this warning. Look at this. And I'm going to keep this up here. And then we're going to go back to it. But before we do that, I want to show you that you could have a function call on other functions. There's nothing wrong with that. Millions of programs in your operating system do it every second. So here we defined a function called print lyrics, right? It prints I'm a lumberjack and I'm okay. Let's test that. Print underscore lyrics. Gotta spell it right. Oh, what happened? What's going on here? How come none of my functions are working? Is it a me thing? Is it a Python thing? Take 0 positional arguments, but 1 was given. It's still angry. Well, I want it all. Print lyrics is just the definition statement, and inside are just 2 print statements. So it should just print them. Let's close this. Let's rerun it. Drag this back over. Let's see if we get the same error again. I'm going to call on print lyrics. Open, close. Now it worked. Let's talk about that beginning when I tried to define something called print on my own. And ever since then, I got errors. In memory, I still had a function called print. When I would type this in to fire, Python read it up to here and try to fire what I already called print. But since it was a malformed function, I was getting the error from that particular defined function and not the new one. If you ever find yourself beating your head against the wall going, I know this code is right, why won't this shell show me what I want? Perhaps you've been working that shell too long. You could either restart the shell to clear all your variables and then rerun your code, or close it and restart it. That's it. That was all proof in the pudding, me running through this to show you how horrible it can get. But that it is wild. But if you think about it, it's correct. I defined something called print, and then I try to call on something called print, but it just was like print, done, boom, broke, right? Now, it shouldn't have, for all intents and purposes, but it didn't like that underscore. It sure as heck didn't read the rest of it. One cool thing that I want to show you, again, is ID. I don't think I need that. Let's see. When you do the ID of your function, it gives you back a memory location for that shell while your script is running, that function that you defined truly is available in memory. Cool. Helpful if you're doing some twisted logic to check if it's there first, or if your program is long and you fear that something restarted in the back end, you can always check it. It's there, not really to use as a validation, but it can come in handy. So ID is kind of cool. But let's define our second function. We're going to define our second function called repeat lyrics. And repeat lyrics is actually going to call on print lyrics twice. Well, before we do that, let's close this. Let's get a new shell open. Let's define our second function. Repeat there. Let me just cut and paste this. Now I'm going to call on repeat lyrics. What do you think is going to happen? Any takers?
It's just gonna do the output of I'm a lumberjack and I'm okay twice.
Well, I killed my shell and restarted it, and I never defined what print lyrics is.
Then never mind, it's not gonna do anything.
No, well, I'm glad you brought that up, though, Logan. You've been up all day. You're tired. New stuff. This is my job to show you and make you think. Even when you're at your most exhausted, my job is to make you think, right? So I started a new shell. This shell has no idea what print lyrics is, but it knows what repeat lyrics is. Then I get this crazy error. Print lyrics is not defined. Okay, no worry. I grab print lyrics. I define it. Now I'm just going to call on my repeat lyrics again. And now everything works. This proves to you that it doesn't matter what order you define your functions. It matters on what order you call on your functions. Think of that. Ever since up till now, we've been running scripts straight down, top to bottom, top to bottom, top, a loop, to bottom, top, a loop, to bottom. Now we can go define, do something, define, call on our first function. Our first function will call on our third function. Our third function can call on our second function. Our second function can call on a function from something else. You're not restricted into top to bottom. Your only restriction is if it's defined in memory prior to you calling on it. And it tells you, I'm not defined. Isn't that cool? And I'll show you what I mean. Like we'll go through some coded examples. These are important notes. A lot of times you'll hear me just riff and freestyle. These notes are pretty important. Actually, I call them important, right? Function definitions do not alter the flow of execution of the program. They don't. But remember that the statements inside the function are not executed until the function is called on. In other words, define your function, give it statements, call on your function, green light, go. That's it. It's like a detour. I don't like that analogy, but it is. It sounds simple until you remember that one function can call another function. One function can return a value and give it to another function to do something else with. That's pretty cool. We're going to get to that. And here we go with some more fun examples. So let's take a look at this first one. Define hello. Hello, Prince. Hello, howdy, boom, this is over. Okay, that's pretty self-explanatory. Well, what does this prove? Well, you could have more than one statement. That's all this proves. Let's call on it first. Let's call on hello, open, close. What does it tell me? It's not defined. So let's define it. Now let's call on hello. And it performs those statements as designed. Cool. Well, can we do message equals hello? What do you think's in message? Nothing. Why is that?
Is this the part where we need a return statement?
Bingo. So functions, if you design them just to run print statements or any statements, it'll do just that. Now, if I wanted to return a value, like let's redefine this. Keyword return. And now it could be a culmination of anything. Now, and I know that sounds overbearing, but check this out. I'll just return, hello, Tim. I'll do hello again. At the bottom, it says hello, Tim. Check this out. Message equals hello. You notice what I return is no longer put to the screen. Standard basic output is output to the screen, right? Returns coming up in your book. I'm talking about it now. We haven't hit it yet in my next notes, but we're doing it now. We'll get there in a second, though. We'll get more detail. Return allows you to pass a value outside of your defined statement into, you guessed it, a variable. So now when hello runs, it says, hello, howdy, boom, this is over. But when I call out a message, what do you think's in message? Hello, Tim. Now, let's create another function, define, we'll call it test1. We'll give it a parameter of x, and we'll say, okay, cool, test1, and I'll say print, this is cool, comma, quote, comma, x, close, right? So when I call on test1 with no parameters, I get missing positional argument. Okay, so let's give it one. Let's make sure we have our message still. And that was ran from what? Let's rerun it. Let's rerun hello. Hello, Tim's not there. Hello, Tim's in message. And now let's call on test1 and let's pass it the message. What? That is awesome. We were able to run our initial hello function, return an output to the screen, gather data from a return statement into a variable called message, pass that variable of message to another function called test1 that took a parameter of a string. And then when we called on test1 with our returned value from our other function, you get this is cool with the value of hello, Tim. You see how powerful this could be? What if you wrote a function to ping every system, a list of systems, ping these 10 host names. If they're online, tell me they're online, and then check to see if this update's there. Return the list of online, no update, online, no update, online, no update. Could you return that in a value to another function that goes, if in this list online, but has a 1 or 2 that it needs the update, to push the update to those machines? Totally. You can get really tricky with this stuff and have a kick butt day. You could write a function called, I don't even know if we do it. I don't want to wreck it. I added a whole bunch of stuff to my notes. Let's just do it. Forget it. We'll just run through the notes. Why not, right? That's why we're here. But lesson 4 is super powerful. And I mean that. Like, it is so much fun. Let's see. Did I add anything to this? No. Okay, yeah, we get pretty wild here. Yeah, we'll run through all of these. So the cool thing about functions is it's reusable code. You could define a function, first name. What's your first name? Return first name. Write a function, what's your middle name? Return middle name. Write a function, last name, return last name. You can write a function called put the name together, and you could call on each of those functions and put your name together, get each of the variables that were returned, and then say Zachary James Wojton. Cool.
I have a question.
Yeah.
Can you define a function with an input statement? So define first name and then equals to an input statement?
Yes, but for now, don't.
Okay, sounds good.
And you could also define functions within functions. They're called nested functions. But much like if-else statements, those functions only reside inside that function. So if you call a function like get first name, And then if first name equals true, get last name is nested. You have to return both values of first and last, or outside of scope. Python doesn't know what last name is.
Is that because it's not a global variable or something like that?
So let's talk about scopes. I'm glad you brought that up. We'll do a new file. We'll just we're off the rip here. So let's define test one, open, close, and we'll say print one. That's good, right? We'll define test two. We'll give it a variable, and we'll say print x, right? Now up here, we'll define a variable called var1, and we'll give it Tim. Now at the end of this, we're going to say test one, run. Test two, var1, right? Then we're going to say test one again. I'll just say, let's see, scope test. I'm going to hit F5. You're going to see that it prints one. There, I'm getting both on the screen. It prints one. It'll print our variable of Tim. It'll print one. What if I went and test one? I did a variable 2 equals, let's say Doug, right? And I called test 2 to call on variable 2. Scope. Now, you'll see var2 is indeed defined. We call on test one first. It prints Doug. It prints 1. Then we call on test 2 with var2. Test 2 has no idea what var2 is. var2 is what's called local scope, and it's local only to test 1. Now, Tim up here, sitting in var1, test and test 2 can use var1 because they're what's called global scope. You could also define globals by global and call it var3, right? And when you call those globals, you could say global var3, or call on them just by var3. No, if you define var3 on its own, oh, this is where it gets weird, right? So you could use global. Now watch this. You could say var3 equals, well, now you're defining it locally. It's not global anymore. Let's prove that. var3 equals, I don't know, we'll say var3. Keep it simple. var3. And now we'll say print var3, right? Now out here, I have var3 defined as global, and I'm just going to write print var3. Save it, F5. Ooh, look at this. var3 is not defined. Did you mean var1? So even though I said global var3, it's empty. Doesn't exist. Can you do equals test 2? Nope. Invalid syntax. You have to recall variable 3 and then fill it. Well, let's just take a look at this really quick. So global var3, let's do an ID on var3. And then let's leave all this here. Then I'm going to call on var3 again, and I'm going to say equals test 2. And I'm going to do an ID of var3 again, and then I'm going to print my var3. What happened? var3 is not defined. Did you mean vars? What happened here? This isn't working very well, is it? Now, don't be afraid of this. This is a natural instinct, right? Global's supposed to do. Global defines a variable to be global, but I'll show you how to use it correctly. So I try to define a global variable that's already in global space. You can do it. It's just not the best, right? Like we've proven that you could do it by getting rid of that. And it actually does what? Test 2, Doug. So it does all this. Where did it break? On var2, as expected. But it did all this just fine, and it even ran our functions. You could define global variables by using the term global. Gets a little weird, though. And what I like to do with global variables, either define them all up top or all within my function. What do you mean by that? Well, I'll get rid of this, and I'll call on global var3, and I'll get rid of this, and I'll get rid of this, right? So now here, let's just follow this. Test 1 is going to declare a global variable var3, and then right underneath it, I'm going to say var3 equals, and we'll say test G for global. Then it's going to define var2, which is local. It's going to print Doug. It's going to print 1. That way we know we're in test 1. And then I'm going to return. What should I return? Should I return the value of var3? Follow this. Test 2, var3, we'll just let it ride. Doug 1, name var2 is not defined. You mean var1. So where did this break? Let's think where it broke. I called on, it broke right here. This was our test. We can't call on local variables, right? Well, what if I call on var3? Why'd that work? Test 1 defines a global variable. It then puts a value in it. Then this is all local. var2 is printed here. Print 1 is just a print statement. Then I return var3. Well, where do I return it to? I don't store it in a variable. I return it to the global construct of Python. So if I go over here and I actually type var3 and hit enter, it knows what test G is. It pushed it back to global scope. So when I call on var3, equals var3, but what happens here? Test var3. So test 1 returns var3, which is test G to global scope. Then when test 2 calls on var3, it knows var3 as this. So when you notice it overrode this. Oh, or it didn't. It also printed that too. You see the var3 there? Is that from our first, our second call?
It's from your second call.
It is. So you notice you could have a local and global variable with the same name.
We're all screwed.
No, this is a very egregious demonstration. This is after your logic is screwed. You didn't pseudocode anything, and you're just pumping in variables where you think they're going to solve a problem. This is what most people do, right? Yeah, the lab itself is not that bad. Rock, paper, scissors, RPS. We'll talk about setting that up here in a minute. But to take away from this is when you start doing this dance, start doing what I've done. Start commenting out and logically going through your code to see what you've actually scripted. Now this is where you become dangerous. Simple is best. Complex is better than complicated, right? There's going to be times where you're going to have to do this. Not in this course. Very simple. At the very most, we're going to use return and do some values. This is an extreme course or extreme case. We're going to come back to it. I want to talk about some easier ones. Well, not necessarily easier, just more bearable, right, for where we're at. So print twice, the phrase. So let's talk about this. It says print twice the phrase. Okay, cool. Well, let's grab this. Let's define this. I'm going to hit enter twice. I could do an ID on print twice just to make sure it's available. Or I could try to run it on a break. It's available. So now I say print underscore twice any parameter I want. This is a new phrase. It takes that argument, passes it to where the variable is in the statements, and prints it twice. Handy. Cool. You see these other different things, and you can get pretty tricky with it. Exactly. Works awesome. Right? Let's see. Use it a variable. We could do variable. We could actually use input too. So what if I said the phrase equals this is a test, right? And now I put print twice, print underscore twice. And then right here, I say the phrase. And now you put a string inside of a variable. You pass the variable to the argument. The function took your argument, which is holding an object, which is a variable, and printed it once and printed it twice. Super cool. If you need to print something twice, right? And this is a function with multiple parameters, right? So now we're getting into A and B. Let's run through this one. This one's kind of fun. Let's take a look at this. I'm gonna hit enter twice. So we defined print maximum, A comma B. You notice there's no equals. It's just what they are. You notice there's no equals up here. That goes back to our errors we were getting earlier by making something equals mandatory. So now we have two parameters, A and B. Print max. This we've seen before. If 5 is greater than 6, print 8. Nope, false. If 5 is equal to 6, false. Else 6 is maximum. Let's use that exact thing. We're going to print underscore max. Now we're going to compare our A and B arguments. We're going to say 5 comma 6. I'm going to hit enter. Did all the hard work for us. It says 6 is maximum. Pretty cool. It's handy, right? And this is us directly passing interval values, the print max, and you could use variables as well. You could say, this is where it gets sloppy. You see programmers doing this. X equals 10, Y equals 3, hits enter, and they do print max, and they'll call on X and Y instead of the values. X comma Y, but this is why they do that. Watch, X comma Y, min max. 10 is maximum. Well, what if I wanted to know, what if I had Y first and then X? Well, 10 is still maximum, no matter which way you put them. These variables of X and Y are taking the place of A and B. Pretty cool. Let's do it with letters. Will it return Unicode values? No, it will not, unless you request Unicode values, which you're not allowed to use in your next lab, because I remove the availability for you to use ORD and char. I say don't do it. But that's not until the next lesson 5. Unicode values in this course are of next to no topic at all, because we're not intermediate level yet. We're not parsing logs. We're not looking for Unicode values. We don't do that. We don't even cover what they pretty much are and why Unicode is the standard and not ASCII, and we don't get into that. That's more of a higher level. As you progress through Python, you'll understand why, right? But we'll get there eventually. So they have this concept in your book called fruitful functions. Well, we've already discussed those. Fruitful functions are simple. They return something by using the return value, right? The return keyword. So here we run through this X and Y, we return Y. Then we print maximum. It doesn't really happen. So let's see a customer account number change. This is pretty funny. Hypothetically, you're writing code. You know you need to write a function that does this function. You need to write something that does the customer account number change, but you never received a standard for the account numbers yet. Fine, write your code, define your function, no arguments yet. Your statement is pass. What does that mean? That means your function exists in memory, but if you call on your function, it doesn't perform anything. It simply goes, oh, you called on me? Pass. I got nothing for you. It's a placeholder that allows you to go back. Or if you already created a bunch of code and you're like, man, I don't need that function anymore, you can simply comment everything out and just put pass in it. And everywhere where that function is called, it will not perform anything. Pretty tricky, pretty cool stuff. Starting off, I very rarely see folks use pass. As you move up in like more complex scripts with like 5 or more functions, I see you start to use pass more when you're developing. And then you go back and fill them in, and you make sure these 3 work right, then you go back and define your 4th function. I see that all the time. Yeah, this is the name one. Oh, you can do this too, right? So let's do this. Let's define name. What is your name? I'm going to hit enter. I'm going to put Zach. So now Zach is stored in name. I'm going to define a function, kind of off. Usually you define everything, but we'll just go with this, right? Name input string. What is your name? Zach. Define hello to name. Print hello plus name. So what do I do here? I simply call on hello to. What if I hit open close? Required 1 missing positional argument. Well, I'm going to give it name. I'm going to give it back the name because in theory, name should be holding Zach. It sure is. So now everything you've learned from gathering input can be turned to a variable and then passed to a function as a parameter. Pretty cool, right? You know how to do a lot of this stuff already. So here we go. So here we talk about parameters. A parameter is a variable. Let's make this big. That an argument is stored in when a function is called. One important thing to note about parameters is that the value stored in the parameter is forgotten when the function returns. So what does that mean? I just called on hello to name. Well, can I do hello to and then pass it Tim? Yes, because name, even though I used it twice, which is usually bad, but here name is empty and allows me to put anything I want back into that parameter, so it prints out Tim. The rule of thumb to stay away from is don't name your global variables the same as your parameters or as your local variables. Python will let you. There are places when you need the same variable name in local and global space out of scope of this class, right? Just know Python will let you. Because Python goes, oh, you want a local variable one and you want a global variable one. No problem. This function only knows about this variable one, but it also knows about that variable one. What? Let's go back to our scope test. So where's the weird stuff here? I got a global variable 3. We defined 3. We got var2. We return var3. All this fun stuff. I'll just hit F5 here. Now, hold on. I have a var3 that's vars and a var3. Well, var3. Well, var global's going to win because right now I'm calling it from global scope. And I said global var3 test G. That's the one that's returned to global scope. So when I call on var3, I get my test G. But you notice here, var3 equals var3, print var3, print X. How come var3 never prints here?
Because you commented it out test 2.
There you go. Now let's try this again. And let's say test 2 is just print X. So we're going to print Tim again. So let's follow this. var2, print Doug, print 1. Doug 1 is right here. Right? That's our first call with that. The highlighted ones are what we're calling on. Then I say test2 Tim. var3 equals var3, print var3. var3 is this line right here, those two. And then I say print X, which is my parameter, or Tim. Then I call on test1 again, and I say test1, I get my Doug and my return. But when I call on var3 globally, I still get test G. That proves that you could have a local variable, local to test2, that holds a different value than when you return a global variable with a different value.
I have a question really quick.
Yeah, hit me.
Can you just remove var3 equals var3 in test 2 and see if it prints a global variable? I'm pretty positive it will, but I just want to see. Yeah, now it makes more sense in my head.
Bingo. So what Logan pointed out to was, that was you, Logan, right?
Yes.
Okay. So what he pointed out is when I comment this out, I just say print var3. Well, since test1 ran first, it defined the global variable 3, it gave it a value, and then it returned it to the global space. When test2 ran, it said print var3, which now test2 knows about the global variable 3, which is test G. This is an extreme case. I want to show you that you can do this. These are things that you one day will take advantage of, and maybe someday soon. But for all intensive purposes, global scope is global, Local scope only belongs to that function at that time, and then it's just emptied out. Super cool stuff. Any wild questions so far? Because it's fine if you have them. I'm expecting. I'd be surprised if there wasn't any. Right. And this is kind of a repeat of parameters. Right. Inside a function, the arguments you can read. Everyone's going to read. This is straight out of your book. I'm not going to insult your. I'm not going to insult your intelligence, right? But check this out. Define function 1. Takes 3 parameters. We print backwards, forwards, and then we print just the middle. And then we call on it. We give it 3 strings. That's pretty handy. What if you had what if these were lists and long lists, and could you do all this? Could you find the min max? Could you find the value? Could you do anything you want inside these statements? Yes. This one function performs 3 tasks. What if you were given every combination of every 3 letters ever, and you were said, hey, how many make words? Forward, backward, and what's the most common middle letter? Could you find it through the entire alphabet if you were given all those parameters? Yes. This is what large language models do, except more, but this is the infancy of it. This is the beginning of how we got to where we're at training AI now. Small little steps. Can you do this repeatedly over and over to this data? Is it accurate? Is it the same? Okay, cool. We'll keep this part and let's build on it. But I mean, that's pretty handy. You'll learn how to do this even cooler in lesson 5. You'll learn that there's reverse methods for strings. So you can actually reverse whole text and do all kinds of fun stuff. But very handy, right? Do parameters and arguments make sense to you?
Parameters and arguments make sense. I was a little hazy on the return.
The return, just if you don't store it in a variable, the default is to put it out to the screen. Like if I just did this, return Tim. Oh, how come Tim didn't do anything?
Because you didn't save it to a variable?
Well, I mean, what if I did this? This is going to get wild, right? What if I hit print? Print and then run my function. The function of print tells function 1 to perform its task. It does it. It returns the value of Tim to print to also print. Yeah, exactly. Right? Now, that's cool and all, but this is better. Like if you want first name, I'll just put that equals function 1, and I'll do the same thing of whatever we had. I can't remember. This right here, I'll just cut and paste this. And hit enter. And then I'll say print first name. Now, first name should only have the return value of Tim in it, but this function will print these 3 lines to the screen, return Tim into first name, and then I'll print out your first name is Tim. Cool. So you could store return values in the variables. Now, what if we return more than one item? What if we separate it like this? Can we do this? Oh, what happened? Second name, you're right, because I did this. You could return multiple values from a function, which you could later, like, if we had another function, well, let's just stick with this. I told function one to perform its function on A, H, and Y. I then said first comma second name equals function one. So I have to know in advance that function one is going to return 2 items. It stores Tim in the first name and Zach in the second. And then I'm able to use them independently. You're right. Just a couple more weeks. Super cool. Well, what if I had a first and second, but I only returned 1? You're going to get an error. Now, can you do things like define middle and say print middle equals Y, and then do things like middle equals what? Well, middle will equal Y, right? Because that would be the middle parameter, and then return middle. Yes. I know this is wild. Think of everything as an object. You heard me been saying this from the beginning, right? Everything is an object. You can return different objects to what you manipulate. Store them in a variable name of what they're called and benefit from how awesome your code is. Super fun stuff. Now, we're not going to get into too much more weeds here. Let me see. Yeah, we got some time, so let's. I don't want to get into the games yet.
Really quick before
Yeah.
we move on,
Yeah.
can we return just the return statement from that function instead of
So
putting out the function? Just return to the middle.
you could get rid of all this, comment it out in your script. You could do whatever you want.
No, I mean, like, let's say that is still there. Is it possible to just get the return?
Well, since we're telling the statement is actually saying print to the screen, so you're always going to get that print to the screen. You know what I mean? The
I
statement
got you.
itself. Yeah.
So let's say we had a
Now you
variable.
can say if.
Yeah.
You can say if y is equal to, what do we say it here? H. Then do all this. Oh, this gets cool too. Because then you can say else. Ooh, this is going to be fun. Because now you open up a bag of worms I just love. Or you can say else. How cool is that? What do you think? So if y is h, in our example, y will be h, right? I need to define it first. So I'm already jumping myself. There you go, jump. So now we defined it, ran it backwards, right? Forwards. Y was H, so you got your backwards, forwards, middle, right? And then it returned Tim. Let's design this just to return middle for both, because you don't want to return everything, right? Let's go. It's going to return middle, so we'll call it middle name or middle letter. Middle letter. That doesn't exist anymore. So H is H, right? Now else return middle. Well, can I do middle equals Z? And now down here, I'll give it an R. That's kind of cool logic. What do you think? Or
Great.
you could say middle equals Y. And then in theory, whatever I put in Y, the Y spot, should be stored middle and returned. So now we get R back. And that's all we get without the prints. This, through the reading, through the challenges, through these videos and us interacting, you're going to realize that you can really almost do anything. And after lesson 7, you're going to be able to create reusable functions that create data, store it in files, remove it from files, throw it to new files, create new data objects, objects of objects. You're only going to be limited by your imagination. Gets overwhelming for some. I'm trying to take that out step by step, slowly. Don't go for the gusto. Learn everything well, not learn everything. Leverage everything we've learned up to this point, and then slowly add tricks of the trade as you do the challenges and understand each one. That makes sense to everybody? I'm not here to scare you. Trust me. And next week, we're going to do the group activities together, and everything to go, this isn't a rush. We got plenty of time to master these concepts. For those of you who take the time to master these concepts. And I'm not asking a lot. 2 hours a week. That's 4 hours over 2 weeks. It's probably about the right amount of time for a 2-hour or 2-credit class. Your other classes, you should be doing 4 to 8 hours a week. Because trust me, when you get outside of Columbus State and you pursue higher degrees, those letters in front of your classes that change from 1 to a 2 to a 3 to a 4 to a 5 to a 600 level, they demand more attention. And it's not on the fundamentals. They expect that you've understood the fundamentals and you use those fundamentals to solve the problems within your 400 and 500 level classes. That is not the time you want to go back and relearn something that you should have learned. Has anyone ever had that broken down for them like that? Because that's important. And time is of the essence. The more you go out with your, the more you push yourself in academia, you should become better, become more powerful with all the tools that you have built on Build, right? It makes sense, just like this course. It's kind of built for success. I want you to succeed. Trying to group activities will do, lab directions will do. Let's talk about the return test. We've already been through that. We're going to go through a lot of these next week too. Let's talk about the math module. So here I'm going to hit shell, restart shell. All my variables are gone. It's like starting brand new. It doesn't know what func1 is. I get an error, it's not defined, even though I just ran it. When you restart your shell, it trashes the memory and just gives you a fresh shell. Import math, enter. dir on math. This is the equivalent of a TI 8485 calculator. Pretty much. You could add more power to it. Python has wild math modules, has scientific, it has all kinds of, anything you need to solve, most things are already pre-built. You just need to know where they're at. So here, when you do a dir on math, it shows you what's in math. So cosine, sin, pi, it knows what pi is. Well, how do you call on pi? If I just call on pi, it's like, I don't know what pi is. If you call math, the module name dot the method, then it knows what pi is. it doesn't know what you mean by when you put parentheses after it. It's a float object is not callable. So pi returns a float object. Cool. That's okay. Do we know how to format? Well, we could say, we could do this again, right? Call on math, round, math pi, comma 2, close, and now we got math pi rounded. Helpful. Gamma, sum, sin, what's another? Cosine, what's sine? Sine, is it? Is that all of them? I think so. Blah, 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 blah. It has so much fun stuff within this math module. You could lose your mind. We're using very simple math, square root, sin, pi, the power of, prod. I think that's all we're really touching. Is finite, is not finite. Those are terms we could discuss at a later time, but they're not really for this course. But the floor, factorials, all kinds of fun stuff if you're a math geek, right? But we'll primarily use pi, square root, and power of. So that's about it for the math module. How do you get help on stuff in the math module? What if I want to get help on sin? Help, math, built-in sin function math module, x, backslash return the sign of x measured in radians. So now it starts to get kind of like, okay, do I need to know math? What if you did this? It expects keywords. Like, I don't know, let's just throw something in here. Let's just, it won't know what that is. It'll be invalid syntax. 44, 202 squeeze lines. Now it'll tell you all about when you call on an integer, right? So just be mindful of how you use help. If you want to get a method help right away, you call on the method with no parameters, and it'll tell you a brief synopsis about it. If you want to get in-depth help on a method of the math module, you have to fulfill one of the requirements, one of the parameters, right? That's it. Now, what are these dunders called? Double unders or dunders? Any Office fans, Dunder Mifflin? But anyway, the dunders have a special place. They're usually built-ins. You'll hear the term built-ins later on in intermediate Python, but I just wanted to drop that dime on you now. And that is it for this evening's lecture. I'm going to go ahead and pause the video here. Stop recording.